This is problem 7 from our review sheet. It references problem 11 from the Chapter 8 review. A store has a special on bread with a 5-loaf limit. The probability distribution for sales is listed in the following table. Find the average number of loaves per customer. So the store no doubt kept track for some time period of how many loaves of bread customers would purchase, and they converted that information to a probability distribution. Probability distribution could also be thought of in terms of percentages. So when the first figure is 0 and the probability is 0.15, so this is the number of loaves, that's the probability. Basically, 0.05. Need my glasses on here to read that small print. Basically what that's saying then is when the store kept track, 5% of the customers didn't buy any bread. As far as 1 loaf of bread, the probability distribution was 0.20, or that would mean 20% of the customers bought 1 loaf of bread. So when it asks us to find the average number of loaves per customer, what it's really asking us to find is the overall average. In other words, if we kept track and we added up all the loaves of bread and divided by all the number of customers that had come through, then that would give us the overall average. That would give us the average number of loaves of bread per customer. But that's also the concept of expected value. So we can calculate from these values and these probabilities, we can calculate the expected value. And remember, the way we do that is we multiply these quantities and take the sum of the products. And that's the expected value, which in this case then would be the average number of loaves of bread purchased by a single customer. Well, 0 times 5/100 is going to be 0. 1 times 20 hundredths is going to be 20 hundredths. 2 times 15 hundredths will be 30 hundredths. 3 times 20 hundredths will be 60 hundredths. 4 times 25 hundredths would be 1, and 5 times 15 hundredths would be 75 hundredths. So if we take those values and add them up, so 2 tenths plus 3 tenths plus 6 tenths plus 1 plus 75 hundredths gives us a value of 2.85. So the overall average number of loaves of bread purchased by a given customer, a customer picked at random, we would expect that they had purchased 2.85 loaves of bread. Now, of course, nobody ever purchases 2.85 loaves of bread. But this is the overall average, the expected value. And we calculated that by using the values and the probability that each of those values would have occurred. Well, now, if we expect on the average to sell to a customer 2.85 loaves of bread, if we finish up that problem, it says if the store expects 380 customers for the day, so there are going to be 380 customers for the day, and an individual customer averages buying 2.85 loaves of bread. Well then, wouldn't we multiply those two together to give an estimate of the number of loaves of bread we need to make? And that's what the question was. How many loaves of bread are needed? If you had 380 customers and the average number of loaves of bread they bought was 4, wouldn't it make sense to take 380 times 4? Well, just because this is a decimal value doesn't change that approach. The average number of loaves per customer is 2.85. If we have 380 customers that we expect, we take that 2.85, multiply it by 380, giving us an answer of 1,083. So if we wanted to make sure we had enough loaves of bread, we would want to at least make 1,083 loaves of bread. Is that, based upon our previous experience, should handle 380 customers?